Hello everyone, let's look at question 1. A tennis ball is hit straight upward with an initial velocity of 2 meters per second. The mass of the tennis ball is approximately 0.05 kilogram. Air resistance X on the ball is equal to 0.5 volt. Let's look at question E. Question E. Develop the function of the ball's velocity in the function of time. First, let's take out all the infos from the question. For this question, we will be using Newton's second law of upward motion and also Newton's second law to develop the function. Here, F equal to ma, where a equal to dv over dt. And when we substitute, we will get F equal to m dv over dt. Next, we substituting F into the Newton's second law of upward motion, which is m dv dt will be equal to negative mg minus kv. We divide both sides by m, and we solve it, and we will get dv over dt will be equal to negative g minus k over m v. We arrange the equation that we got just now, and the equation will be equivalent to the standard form of linear differential equation, which is dy over dx plus pxy equal to fx. Next, to solve this linear equation, we need to find vt. Vt is equal to exponent to the power of integration k over m dt. We solve the integration and we'll get vt will be equal to exponent to the power of kt over m. And next, we will proceed to multiply the equation both sides by vt, the integrating factor. We expand the equation and we will get at the end of the equation, at the end of the left-hand side equation, we will get the product of the integrating factor vt and also dependent variable v. Next, we integrate both sides of the equation by using u substitution. Here, u substitution equal to kt over m, and we solve it and we'll get dt equal to m over k du. We substitute the value of the u substitution into the equation and we will get negative g integration of e to the power of u m over k du. We put the constant coefficient at the front of the equation and it will be negative g m over k to integration e to the power of u du. We solve the integration and we will get negative g bracket m over k eu, and we substitute back the value of u, which is it will be negative g bracket m over k e to the power of kt over m. Hence, after we integrate, the equation will be e to the power of kt over m v equal to negative g m over k e to the power of kt over m plus c. Then we divide both sides by e to the power of kt over m. We simplify it and we will get v equal to negative g m over k plus c e to the power of negative kt over m. Thus, we continue and we let the k over m here, let p equal to k over m, where k is the air resistance divided by the mass of the ball, which is 0.5 divided by 0.05, and p will be equal to 10 second negative 1. And then we substitute back all the infos that we got from the question, where g, the gravitational force, equal to 9.8, and mass of the ball 0.05 divided by k, the air resistance 0.5, plus c e to the power of negative p here is 10 second negative 1, and also t, and vt will be equal to ce to the power of negative 10t minus 0.98. Furthermore, to find the value of c, we need to substitute t equal to 0 and initial velocity 2 meters per second into the equation. We substitute and we solve and we'll get c will be equal to 2.98. Lastly, we substitute the value of c into the equation, and finally, we have developed the function of the ball's velocity in the function of time, which is vt will be equal to 2.98 e to the power of negative 10t minus 0.98.
Next, we are going to discuss question B. This question asks to determine the time that tennis ball reached its maximum height. Note that when the ball reached at the maximum height, the velocity of ball in the function of time is equal to 0. Here's the other information to answer this question. The gravitational force at gravity is equal to mass times with gravity, where the gravity g equals to 9.8 meter per second square, and the air resistance Fr is equal to negative k times with v, where k is equal to 0.5 kilograms per second. The initial velocity is equal to 2 meter per second, and the mass of the tennis ball is 0.05 kilogram. From the question 1a, we already got the function of the ball's velocity in the function of time, which is v equals to 2.98 e power of negative 10 t minus with 0.98. To determine time which the ball reached its maximum height is by step 1, where we need to set function of the ball's velocity in the function of time vt equals to 0. Then substitute vt equal to 0 because at the maximum height vt will be 0. Okay, for the next step 2 is to solve for t. We bring 0.98 to the left-hand side. Then to find t, we need to divide both sides with 2.98. We multiply both sides with ln to find t. So we got ln 0.98 divided by 2.98 equal to ln e to the power of negative 10t. So then we continue until we got ln 0.98 divided by 2.98 equals to negative 10t. So where's the exponential? Since we multiply both sides with ln, then ln e is equal to 1. So we continue our calculation until we got the time when the ball reached its maximum height at t equals to 0.1112 seconds.
For the question C, which is if the tennis ball is hit from an initial height of 1 meter, how height will it reach? We already know the velocity, time, and initial height. So if we want to calculate the height maximum, we need to let height maximum equal to ht. We will get initial height plus integration 0 until 1 the velocity. So we will substitute the value 1 plus integration 0 until t 2.9 and exponent to the power of negative 10t minus 0.9 at dt. After that, we separate the velocity equation. We will get 1 plus integration 0 until 3 2.9 and exponent to the power of negative 10t dt minus integration 0 until t 0.9 at dt. After that, we will integrate all the equation. We will get 1 plus minus 0.298 exponent to the power of negative 10t, 0 until t minus 0.9 at t, 0 until t. We already know the time of the ball, so we substitute the t value, which is 0.999 0.1112 second. We will get 1 plus negative 0.929. We will get 1 plus negative 0.29 at e exponent to the power of negative 10t, 0 until 0.1112 minus 0.9 at t, 0 until 0.1112. Substitute the value of t, we will get 1 plus negative 0.29 at exponent to the power of negative 1.1112 plus 0.29 at minus 0.109. After that, we will get 1 plus 0.091, and the final answer is 1.019. So we will get the proximal of 1.09 meter as a maximum height.
The question is, a police were called about 3 a.m. on 28 February where a murdered victim was found in the room that has a temperature of 15 degrees Celsius. The police took the temperature of the body immediately after the body was found, and 1 hour later is obtaining the value 34.5 degrees Celsius and 33.9 degrees Celsius respectively. At 4:30 a.m. 28 February, Mr. X was arrested due to murder suspect at the hotel near the murder scenes. According to the hotel receptionist, Mr. X was checked in at 11 p.m. 27 February and never left his room until he was arrested. If the killing time was a factor of the charge against Mr. X, is that Mr. X is the killer in this case, given the body temperature of the human body is 37 degrees Celsius. So, we will discuss this after this.
The case of Noor Kartini Abdullah's murder, which shocked the nation, has seen a suspect remand for 7 days to assist police investigation under Section 302 of the Penal Code. According to a statement from Inspector Syazana, the investigation involved 5 key steps. Pertamanya, kami menyusun dan menganalisis semua maklumat yang diterima semasa ops dijalankan, di mana sekitar jam 3 pagi suhu mayat yang dicatatkan oleh ahli forensik kami iaitu 34.5 degree Celsius, dan mayat tersebut kami bawa ke Jabatan Forensik Daerah Tanjung Malim sekitar jam 4 pagi, dan kami dapatkan bacaan suhu yang terkini iaitu 33.9 degree Celsius, dan untuk masa kematian mangsa kami rekodkan mengikut suhu normal badan manusia iaitu 37 degree Celsius, dan suhu bilik ketika kami menjumpai mayat tersebut adalah 15 degree Celsius. Langkah kedua di mana pakar forensik kami menerapkan Newton's law of cooling dalam siasatan ini, where we make it separable in the terms of differential equation. Seterusnya dalam siasatan ini juga kami menggunakan integration rules di mana kami integrate both side, then we got ln for the left hand side and KT plus C for the right hand side. So macam mana kita nak hapuskan ln adalah dengan menggunakan konsep exponential, and then we got exponent to the power of KT plus C, then we simplify until we got T and label it as 1. Last but not least, kita juga ada apply substitution rule in this case where we need to find C and K. At first, we need to substitute Tm as the room temperature and label it as 2. Next, we substitute pula duration awal mayat dijumpai iaitu 0 hour and berserta suhunya 34.5 degrees Celsius, then we simplify until we got C and label it as 3. And lastly, we substitute pula duration akhir iaitu 1 hour berserta suhunya 33.9 degrees Celsius, then we simplify until we got K and label it as 4.
And now we are at step 5, the last step, which is we need to find the time of death. First thing first, we need to substitute the value of temperature equal to 37 degrees Celsius into equation 4. Then the equation will be 37 is equal to 15 plus 19.5 exponent power of negative 0.0313t, which t refers to time. Since we want to find the time, let 19.5 exponent power of negative 0.0313t at the left and bring the rest to the right. It will be equal to 22. Do it one by one until t is the only one on the left side to avoid confusion. Next, move 19.5 to the right, and the equation will be an exponent power of negative 0.0313t equal to 22 divided by 19.5. Then move exponential to the right, and it will be ln modulus 22 divided by 19.5. Then ln modulus 22 divided 19.5 divided by negative 0.013, and it will be equal to negative 3.9 hours. As we know, 1 hour is equal to 30 minutes. So 3 hours plus 0.9 multiplied by 60 minutes, and the answer will be negative 3 hours 54 minutes. As a reminder, this means the time of death was approximately 3 hours 54 minutes before the body was found. Therefore, 3 am minus 3 hours 54 minutes, it will be 11:06 p.m. Thus, Mr. X is not a killer because the murder occurred when he was still in his room.
And that concludes Nightline this time around. Thank you for watching and stay safe.